Hi, welcome to section 8.4, Linear Inequalities and Systems in Two Variables. So hopefully by the end of this you all will be able to solve and graph linear inequalities and systems of linear inequalities in two variables. So basically, how do I graph a linear inequality in two variables? Because we're going to have x's and y's on this one, which means we have two-dimensional graphs. What you're going to do is graph your linear inequality just as if you would graph a line if it was an equation. So just pretend like the inequality symbol isn't there and that it's an equal sign just for a minute so you can graph that boundary line, okay? If it's a less than or greater than sign, you use a dashed line when you're making that line. If it's a less than or equal to or greater than or equal to symbol, you'll use a solid line. Then you're going to shade one side of the line, and you always have to think, well, which side am I going to shade? In general, if it's set up with y is less than, you're going to be shading down. Y is greater than, it's shaded up. If you have x is less than, it shades left. If you have x is greater than, you shade right. But even with those, sometimes it's not set up in that way, or sometimes your brain is just like, well, which way is up, or which way is down, or which way is left, which way is right, and it gets kind of confusing when you get some really strange diagonal lines. So the other option that I'm going to mostly show you is using a test point, because that will always work no matter what format you're in. So a test point is where you pick a point off of the line, and you just see, is it true or false for that one point? If it's true, then you shade that direction. And if it's false, you just shade the other side. Okay, so let's try a few of these. My first example for you, we are going to do x plus y is less than or equal to 4. So if that was just an equal sign, the first thing I would think of is it's in standard form. I wonder if it has nice intercepts. So the x-intercept happens when y is 0, so my x-intercept would be at the point 4, 0. So I'll graph that. My y-intercept, that happens when x is 0. So my y-intercept would be at y is 4, so it would be the point 0, 4. Okay. When I connect my dots, let's see here. Am I going to use a solid line or a dashed line? Well, it's or equal to, so that means that we will use a solid line when we're connecting those dots. I'm just going to take a blank piece of paper so I make a nice straight line. Here we go. And it is solid. And I'll have arrows to indicate that it goes forever in both directions. Alright, next up, I need to shade. Am I going to shade this side down here, or am I going to shade this side up there? Well, let's figure that out. Let's take an easy test point. How about the point 0, 0? That's always a fun one because it's easy to plug in 0, 0. So if I'm using my test point 0, 0, I would put 0 for x, 0 in for y, and I'm just going to see, is that less than or equal to 4? Well, is 0 less than or equal to 4? Yes, it is. That's a true statement. So, since it's a yes, since that's true, we're going to shade on the side that includes that test point. So we're going to shade this way. Okay? And, for those of you who enjoy coloring, you can certainly get out your colored pencils and make it look super pretty. But this whole area down here is your solution, all of this shaded spot. Okay? Let's do another one. The next example I have for you is x is less than y. Okay, well if I had the equation x equals y, I would probably rearrange it as y equals x. Just switching sides because I kind of like that y equals mx plus b format that helps me to graph. So y equals x would have a y-intercept of 0. If you notice, that's like plus 0 over here. So y-intercept of 0, and it has a slope of 1, because that's 1x. So my slope is 1, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, as many times as I feel like. Or we could go down 1, left 1, down 1, left 1, down 1, left 1, as many times as I feel like. Okay? And let's see, this is just less than. You notice it's not or equal to. So when I connect these dots, I'm going to connect them with a dashed line. Okay? And we still have arrows indicating that it goes on forever in both directions. Alrighty, next up we need to shade one direction or the other. Am I going to shade this top left area, or am I going to shade the bottom right area? Well, I want to show you what it looks like with a test point. So we just want to pick something off of the line. How about, I don't know, the point 0.02. That looks fun. So if I do a test point of the point 0.02, 0 would be my x, and 2 would be my y. And I'm just wondering, is 0 less than 2? Yes, it is. That's a true statement. So since that's true, we're going to shade the side containing that test point. Let's say that we picked a test point way over here, just so that you guys have a nice little other example. What if I put like the point 0, -2 down here? If I picked a point on the other side, I would have 0 for my x and -2 for my y. Is 0 less than -2? No, 0 is not less than -2. So that's how I would know, don't shade this way, shade the other side. Okay, so that's what it looks like to do a test point. Alright, now it's your all's turn. You get to try one and show me how much you've learned.